back to business, gentlemen. In the meantime, my panelists have joined me. 3 here live with us and 1 virtually. Well, let me present them to you. Next to me, Kevin Lammertyn, who is Asset and Innovation Manager of Otary. Dirk Dewettinck is joining us virtually. He's COO of Parkwind. Welcome, Dirk. Do you hear me?
Yes, of course. I hear you.
We're well connected. Okay. Then Dirk Magnus, who is CEO of Sea Power, and Thierry Aelens, the Executive Director of Norder. Welcome, gentlemen.
Thank you.
Now, as we have seen several presentations of the data chain during the life cycle of a wind farm, which was quite impressive for me. As wind farm owners and operators, most of the work during the life cycle of a wind farm is subcontracted to third parties. Now, what is still missing? Are there sufficient data available? Is there room for improvements? Dirk Dewettinck, let me start with you.
Well, first of all, regardless whether some of the work is subcontracted or not, all the data generated during the life cycle of a wind farm is of course owned by the wind farm owners. But there is still a number of things where we can improve. First of all, the transparent and standardized access to all these data for usage in different software and analysis tools, as these data may come from different sources. For example, the wind turbine supplier. There's the collection and storage of some data at a higher frequency than we do today, so we can do more specific analyses. And there is the flexibility in adding new data gathering tools. For example, using remote sensors based on 5G technology, or new technologies for subsea cable monitoring, as presented earlier today.
Yes, so I hear transparent access, that's important. Here you speak about collection storage. What do you think, Mr. Lammertyn?
Well, and indeed, I agree with Dirk that acquisition through the original OEMs is posing some challenges both on the original setup of the data and the standardization and the structure. Is it enough? Well, by definition, our offshore wind sector is strongly depending on the acquisition of data to allow our onshore monitoring, and all developers have invested a lot in it. So based on the current knowledge, I would say we gather enough information, but time will tell, of course. One important point I would like to make is there's also an economical trade-off to be made. For example, we have installed on 10% of our foundations a very extensive set of structural health monitoring systems, which took about 1 to 2 weeks to install. So if you would apply that over the entire farm, it would have a big impact on the planning and also the budget. Unfortunately, as Dirk mentioned, there is indeed an evolution towards remote IoT sensors, which could aid to help expand, let's say, the detailed knowledge that we gathered on these limited foundations towards the entire wind farm by a limited post-installation campaign.
Yes, I can imagine, speaking of economics, that if you collect data, you have to make specific choices. You can't collect all kinds of data, you make specific choices. How do you make these choices? Why do you collect this data and not other data?
You look at the various possibilities out there, and you pick let's say the most relevant data for your use case. So you look at if you have specific use cases at hand, what data is effectively important to bring value to your use case, and that's basically how you define it.
Yes. Now, the federal government is preparing the start of the new offshore wind farm area, Princess Elizabeth. Different companies will start to collect all kinds of data. We mentioned the geophysical, geotechnical, etc., etc. Now, what regarding data sharing? Is that the way forward, Dirk?
Yeah, I think this is definitely the way forward. In the tender regime, it will be the federal government who makes available a certain wind farm area and let various operators or developers bid for this area. And I think to make level playing field, it is of the utmost importance that the federal government or the authorities make available also the data they have.
Yes.
Is it geophysics, geotechnics, whatever we have made or we have heard the whole range of what can be done earlier today. But if the authorities don't do this, it would mean that not all players start off on the same basis.
Yes,
This would be very difficult.
Yes.
I would only make two remarks there. The first is that the data on site investigations and so on should be there in time, right at the right moment, and it must be relevant and adequate. So I would call on the ones who organize this tender that they get in contact with the industry to define the adequate program for site investigations and so on, in order to avoid that they come up with a whole set of inspections, whatever data there is, but that it's not what the industry is looking for. It would mean a terrible loss of time and a terrible loss of money. So this should be clearly aligned. I hope this will be done. But in that case, this is the right way to do, I believe.
Yes, and the authorities are quite important in this. What do you think about it, Mr. Aelens?
But regarding the tender, I think data sharing, yes, it's the right way forward. But as Dirk said, we are facing a changing environment where we've heard a lot of things about how offshore has evolved and all the data gathering, all that professionalization that has taken place in the last years. But on the tender in itself, we are tending now to reduce the cost. That's the reason why that data is being put forward and given to us.
Yes.
It needs to be a playing field, and the mechanism just need to be known.
Yeah. Yeah. I come back to you, Dirk. Parkwind is known for its collaboration with research institutes. Now, what are the next steps? Where do you expect further innovation in data gathering?
Well, we have indeed been collaborating with several research institutes since the very beginning of our offshore wind activities more than 10 years ago. But the data gathering technology has obviously evolved a lot during that period. So now we're expecting further innovation from the deployment of 5G technology, which will allow us to increase the speed and the volume of the data, and also a much higher flexibility and easiness in the installation of data collection devices where we need them. In short, I would call it the Internet of Things in offshore wind.
Yeah. Have you been optimizing the collection of specific data? And if so, what have you exactly done?
Well, we have been optimizing the collection of specific data in various ways. For example, for some purposes, it is enough to have certain parameters every 10 minutes. For other purposes, we may require 1 second data, which is a lot, but which has become much easier over time. We are also expecting further optimization by using data mining and data management techniques already in use in other industries, such as machine learning and artificial intelligence, which was, by the way, already mentioned by
yes. Now, Dirk, if I speak of Dewettinck, that was one of the first installed Belgian offshore wind farms some 12 years ago. Have you been collecting data all these years?
Yes, we do. So all the turbine data has been collected since the beginning, and we are continuing to do so.
Is it useful?
It is useful, and it has proven to be very useful because, as you know, we were the first wind farm installed. We are also the first one where the turbine manufacturer has become insolvent and is not existing any longer. And to be able to take over the operation and maintenance of our wind farm, you have to rely on also the historics. And to give one example, one piece of information we were not gathering from the beginning was the condition monitoring. It's in fact the drivetrain vibration measurements, where you have a whole range of sensors on gearbox, generator, bearings to measure oscillations, vibrations. We didn't have in the beginning what we did at the moment that our turbine manufacturer disappeared from the market. We had to recollect this whole historical data. It took us a couple of weeks to do so, and we lost a couple of months of data. But you need it because you need to have a kind of a footprint of your turbine, the normal behavior of your turbine, to be able to predict or forecast possible failures in the future. So that's why I think it's very important. It's important that you do so on a manufacturer-independent way, that you don't have to rely on your contractor, your supplier, even if there is full confidence, full transparency, as Dirk said. Even then, you need to have to secure your own data, means and to have your backup plan ready in case you would need it.
Yes, I can imagine that in these 12 years you see an evolution in collecting all these offshore wind data.
Yeah, as Dirk said, it's mainly the way of storing, the way of gathering that has changed. And but this is a global evolution in technology that has come across, where before you were speaking about terabytes and terabytes. Now with modern techniques, you can limit the storage, the size that you need. This can only be more efficient in the future.
Will improve more and more in the future, that's for sure. Like Otary is using an advanced monitoring system on its wind farms rental and CMate, providing a lot of data. How many parameters are collected and what is done with all these data?
Yeah. So on rental and CMate, we are continuously collecting over 52,000 data signals, and this is stored. This is needing a storage capacity of 3 gigabytes per day. To give you a little bit of a breakdown on that, on rental we collected about 10,000 signals, and on CMate, which is composed again on the Mermaid and Seastar wind farms, is the remainder of those data signals. So we have really been able to acquire a lot more data, both in the high frequency second domain as in the aggregated signals. And what do we do with it? 3 things. So the first thing is decisions in asset management, and that's both the short-term aspect, which Ronnie explained earlier. So, for example, O&M planning. This is also a handling of alerts and alarms. This is also condition-based surveys, for example. But also on the long-term asset management. And then we're talking about other systems that have been described, like structural health monitoring, DTS systems for the cable monitoring, ICCP systems for corrosion protection, for example. A second thing we do with it is dashboarding and reporting towards our stakeholders. And a third thing is data analytics. And within data analytics, you again have 2 parts. The first thing is event analysis. So, for example, a specific outage or a storm event, for example, you do an analysis of. And the second part is exploration of our data lake. And there we have done, for example, an interesting use case on turbine performance. And we see a gradual move, indeed, as already mentioned, from a more descriptive analysis towards predictive analysis.
I read an article on this whole dual twins, the fact that you collect data from sensors and that you make a dual twin to have a kind of virtual reality simulation. Can you tell me something more about that?
So yeah, indeed, creating a let's say, a digital replica of our physical assets is indeed done, and we have initiated various projects on that. One of the projects mentioned was the soil twin project mentioned by Bruno, but we also have a digital turbine twin project where the aim is to make a farm-wide long-term comparison against the design based on real-time sensor data. So you make a digital copy of your whole farm and see how it's progressing. Another thing is indeed at our offices in Ostend, we have installed a VR room where the entire OSS offshore substations and the wind turbines are copied, and you can literally walk around in it with a VR set. So indeed we can use it for inductions, for electrical safety trainings, for preparation of the works, but we're also extending it with augmented reality features. So for example, by just adding the SCADA data is a thing you can do there. All those, there are still various use cases possible with the VR room, and it's very exciting because it's bringing your offshore environment into your office.
Yes, and it will be very interesting in the future because we will need a lot of people who work in this industry. So it's a good thing. Now, as a visionary, Thierry, how do you see the use and evolution in artificial intelligence and big data?
I think there are two sides, two possible answers to this, because we are in a fast-changing environment, offshore wind, but also in a fast-changing market. On the one side, we are asset owners, and as asset owners, what we want to optimize is our production, our costs, and the lifetime of our assets.
Yes,
try to optimize them. Yeah. And for that, with the data that we collect, we try to turn towards predictive maintenance, lower the failure rates, predict what is going to happen, predict the weather and how our turbines and our plant is going to behave in those circumstances.
React on that.
And then we also gather the health monitoring, etc., in order to see what is going to happen with our asset on the long run. But what is being expected of offshore wind has also an impact on the market, and there are more and more renewables. And if you look on the other side of it, not only the asset management, there is the energy system which is changing. We are adding more renewables. The system, those are fluctuant sources. And based on that, there will be a complete shift of the system where today everybody is used to have electricity out of the socket. It's the production follows the demand. It will be a change of attitude or a change of mentality for people, that electricity will have a different price when there will be more renewable energy, the prices will go down. So you have to push people to use energy when it's the most abundant, the cheapest. And you need to balance both. On the one side, the production, on the one side, the consumption, and there are a lot of research being done based on data on that, and it's completely different type of algorithms. It's different user case. And at some point, you will need to marry both. Our job as asset owner will be to be able to say to the energy system when we will produce, how we will produce, how much we will produce, and they will have to manage the other side, the demand side. Now, one of the answers that nobody has is who's going to marry those two and how is the market going to look like in a few years. But that's basically where AI comes in and plays a key role in this market.
Yeah, that's well drawn. It's, indeed. Now, the data you have collected during the construction, how relevant are these when the park is actually operational?
Kevin made a reference to it. The lifetime, the health monitoring of our system is one of the key. How many years are we going to be able to run? And we touched on foundation design during the speeches earlier. When we design our wind farms, it's based on assumptions. And assumptions of What are the loads that are the turbines going to see? What are the forces they will be submitted to during fabrication, transport, construction, operation? Idle time. Stijn said, your weakest point can be your transformer, but a transformer that goes out, you will be idling for many months. This has a different load case than what you were assuming originally. All that flows into something I would call, to synthesize, a fatigue budget. Okay? So what we do, the entry point is construction. So in construction, one of the first data sets that we gather is the construction stresses, the blow counts and the hammering. We heard about the noise mitigation, and the hammering that we put on our piles. Those forces were assumed to be X. How much was it actually? We know it after construction. And we monitor over the whole lifetime what is happening to our foundation to be able, after X years, let's say 15, 20, to go back to the certification body and say, look, this is what happened with my wind farm during all those years. I still have so much lifetime left. Can I get your stamp? Can we extend my lifetime? And if we don't do that, if we don't gather that data from the beginning, it remains a theoretical calculation.
Yeah, that's true.
And if we do a theoretical calculation, your margin of error is a lot bigger than what you do with the right data processed in the right manner. So if you don't acquire data from the beginning and manage it properly, you throw lifetime and therefore you throw money away.
Yeah. And you have a better overview, you can make more precise decisions. That's why we need all these data. That's clear, gentlemen. Thank you very much.
You're welcome.
Thank you.
Now, to conclude, a few things, I think. Building, monitoring and maintaining an offshore wind farm requires a wide variety of disciplines, that's already clear, and each producing their typical set of data. Now, a bigger amount of data is expected for new wind farms, that was clear, and speed and volume of data will increase. We spoke about the Internet of Things in the offshore wind. From authorities, it's expected that data will be provided for engineering purposes. Therefore, data sharing will be a common concept, but we heard several times how important it is to have your own data. It's not excluding the collection of data for own purposes. Machine learning and artificial intelligence will make its entry into the offshore wind industry for monitoring and operation purposes. These are a few lines to conclude. Before we go further, we listen to some music.